Hello, everyone. Welcome to the AMT Tech Trends podcast, where we discuss the latest manufacturing technology research and news. I am Benjamin Mose, the Director of Technology, and I'm here with
Stephen Lamarca, AMT's technology analyst.
Steve. How you doing on this cold winter day?
It's actually warm.
It's getting warm.
It is so much warmer than it's been. It's been cold.
That's true.
I don't want to be a cold weather denier because it has been extremely cold the past few days.
It was 24 degrees when I got up this morning.
Peter Eelman swung by the desk yesterday while he was waiting to talk to Doug.
Yep.
And he was telling me about like the weather in Chicago.
Yep.
And it's like they're regularly used to like negative 15 like or this time of year. And I'm like, okay, that's not that cold. 20's not that bad. I'm going to stop complaining.
In comparison, it's not cold. But for me, an isolated Virginian, it's cold.
Yeah.
So I was at, partly why it feels cold is because I was there in Orlando 2 weeks ago for two things. We had the Automation and Manufacturing Committee meeting that was held at the A3 conference. So at the committee meeting, we actually talked about quite a few interesting things. So they talk about a balance of technology and business applications, and where they are in the marketplace is, they're still seeing strong demand for automation. Obviously, with the past recent years of issues of human capital and being available, and work shortages, I see a lot of demand of people shifting toward automation, and also there's a lot of market growth, right? Across a bunch of different sectors. If you're not relying on semicon, you can produce as much as you want, and there's significant consumption for that. So they're seeing growth in their automation, but they are running into supply chain issues. Obviously, everyone's aware of the semicon issues, but they're running into issues of just getting wire harnesses, getting connectors.
That's crazy to me. It's not crazy. I mean, it makes sense. If you're going to be short on one thing, why not be short for the rest of it? It's wild.
Yeah.
The prices of both new and used cars are through the roof.
Right.
And we all thought it was because of silicon, but yeah, I actually have heard that wiring harnesses are tough to get their hands on too. But some companies are really powering through it.
Right.
Like, for example, Toyota says they planned on it, but their lots are still a little thin.
Right.
Not that I cruise for new cars that often, but amidst this silicon shortage, I bought a new motorcycle, and all of the dealerships that I went to were all you're gonna have to wait. Like we have test ride models. And if you buy one today, you're going to get it in 6 months.
Yep.
But, that's okay because, that's when the weather's going to be nice. But a few other dealerships, the Japanese motorcycle dealerships that I went to, the only bikes on the lot were Kawasaki.
Right.
So and Kawasaki's not exactly a big brand. I mean, I guess they are big. In Japan, they're called heavy industries. I don't know what that means, but Japan loves using that in their titles, their company titles. But Kawasaki's all over dealerships. They're it's what is normally a motorcycle dealership for multiple brands.
Right.
They're now exclusively Kawasaki.
That's fascinating.
Yeah. So I don't know what they're doing differently.
Maybe no one's buying them. Whoa. Some of the other things we talked about at the committee meeting was the progression of vision technology.
Yeah.
We had a presentation on the very first applications of vision in manufacturing, and then the progression to what the current state of the art. And that was a very interesting look of how far we've come in both packaging of vision systems and the cost, right? So the first one was $250,000 just to see through a part. And they had, disparate systems. So even getting a digital image to someone remotely, because they're using X-ray to check the part, they basically had a camera in front of the X-ray monitor, and then they fed that camera feed, via CCTV to some other station somewhere else.
Oh, wow.
So, it's connecting a bunch of analog systems where, you can normally just take the feed right off the sensor and take that somewhere else. But now you're forced to use, a series of analog systems. So it was a very good look at where we are today and where we have the potential to go in the future.
I also thought, I wasn't there at A3, the A3 meeting, but I saw an article yesterday quoting Jeff Bernstein talking about how robot sales in North America are up 28%.
Yep.
We're up 28% last year, 2021, over the previous year, 2020. And that caused me to look into the numbers a little bit more. And, for a while now, I've been at least a few episodes in the podcast, I've mentioned how South Korea is like an automation superpower.
Right.
They have 4 times as many robots per 10,000 people that the U.S. have.
Yep.
Like the U.S. isn't even in the same league compared to that. But then again, you look at like the other numbers, like population.
Right.
We've got 6 times their population.
True.
And in terms of robot orders, like the number of robots purchased, we're purchasing the same amount of robots as them annually.
Interesting. That's fascinating.
And I think that data goes back to 2017. Cool. But it is cool to look at. Yep. And,
Yeah. And to mention the conference. So I sat through a bunch of different sessions through the conference. So it was the rest of the week. So they had a automation outlook, interesting thing on cybersecurity and industry, which we've been getting into quite a bit.
Yes.
AMT has been writing a lot about automation revolution in digital manufacturing. So not only look at obviously physical automation, but the software side of it. And of course, an economic outlook. So and to be honest, Steve, one of the best parts about the conference was just being in Orlando in the middle of winter.
Right.
I was going to ask you what your favorite winter conference was.
I don't know if so I don't really I haven't really been to many conferences in the middle of the winter, but like around the winter, like,
sure.
Late winter, early spring, and, late fall, early winter. I can't say it's my favorite, but the most memorable is probably SpaceCom. You always get to, like, whenever I hear, like, there's been a lot of additive research, as lately, and, been so for like the past several years. But like whenever, Made in Space comes up, I think back to SpaceCom.
Right.
Or like when we watched the movie Stowaway.
Sure.
And they have a maker bot right there on camera as if it wasn't product placement.
Right.
Like, and you heard me rant about how they have an artificial gravitational field on that space station. It's like, 3D printing works best in 0G. But yeah, that makes me think of that. But also one interesting thing, space automation.
Yeah. Yeah.
Companion robots. Not what you're thinking. I'm not talking about those.
Okay.
But like robots that, astronauts, the small market, the small demographic that is astronauts,
right.
They can't bring pets to space.
True.
And sure, they have other human interactions up there. Like you've got colleagues that you have to sit with for like a year straight. And you only have like 2 of them. And occasionally you get to call Houston or whatever. But, you don't get to cozy up next to something warm and cuddly at night.
Yep.
So there's a lot of like, there's just, well, not a lot, but there's a surprising amount of automation companies that just make these companion robots for astronauts. They'll make like, a robot seal that is like plushy, but also, moves and interacts to your interactions with it. And, has like, I guess, a heater built into it. So it's warm to the touch too. And it's cool that there's a whole different world out there, literally.
That's fair. That, it is interesting when you consider the human element of space. And, it's the world's longest working hours that you're up in space because you're working with colleagues, like you said. Yeah. And, they're one of the first people to, consider remote work when they have to call in back home to Houston and figure things out. So, yeah, that's fascinating. But SpaceCom in general has been a very interesting experience to see, the shift in made in space now. There's a lot of need and drive and interest to do a lot more manufacturing in space.
And as cool as a lot of the companies that we get exposed to and our members are at like IMTS, for example, you don't exactly get to, rub elbows with SpaceX or NASA at IMTS. I mean, occasionally they do, but they're not like wearing like badges there. They're not wearing like flight suits there. They're in like normal civilian garb or business garb, and you can't tell who's who.
Yeah.
But at SpaceCom, they do kind of like advertise that a little bit, and it's cool.
And I do like the shift in
coming home with SpaceX swag,
space manufacturing. So I think SpaceX is launching like 1 little rocket a week or something along those lines.
Yeah.
So if we look at all the equipment, obviously SpaceX is using a lot more reusable rockets, but the manufacturing production needs for space has significantly grown. You've got so many different companies, you got the European agencies, there's a lot more demand for manufacturing for
and the drive for additive manufacturing to cut down on components that go into rockets to make them more disposable.
Yep.
Because a rocket is essentially like a multi-million-dollar, if not like, hundreds of millions of dollars for investment to something that is essentially disposable.
True.
It's thrown away.
Speaking of which, let's get into some articles. You've got a good one on additive.
So I've got a great one from Additive that, well, it's not that great. It's from Hackaday, which is more of like a consumer news source, but they reference, and of course I let my computer fall asleep on me. They're talking about 3D printed radiation shields getting put to the test. Cool. And they reference a white paper on the use of what are essentially consumer grade 3D printers that are printing with thermoplastics.
Yep.
Specifically, they talk a lot in the white paper and in the article about PLA.
Right.
And there are a select few hobbyists or people that have small businesses that require, maybe it's agriculture or farming, or you have a vineyard or what have you. Some people have their own weather systems, like their own outdoor weather systems, instead of relying on a shady weatherman that's going to tell you it's going to be sunny all day and it ends up raining. They can make their own judgment specifically for their area because they have the tech for it, and there's the availability of things like Raspberry Pis that allow you to make your own weather radars effectively. The problem with that stuff is those fragile PCBs and single board computers. You don't necessarily want them to get wet if it does rain. You don't want them to be exposed to the elements. And even if they're not exposed to the elements, like even if you have perfect conditions, a lot of those fragile computer chips are affected by the sun's radiation.
Sure.
So how effective is printing a simple shield with PLA?
Good, fair question.
And PLA does a decent job at protecting radiation. However, it does a terrible job at holding up against the elements. And the paper talks about how PLA radiation shields degrade considerably after 30 days and effectively are totally destroyed and scrapped or scrap material after 90 days.
90 days. That's fascinating.
And PLA is extremely accessible, especially to a consumer with a 3D printer.
Right.
But they also determined at the end of the article, they concluded that an ideal substitute, and this is all like information that the industry already knows.
Right.
But they conclude at the end that, an ideal replacement for PLA is ASA.
Okay.
Which is just... It's chemically the same as ABS plastic, but it doesn't require as high temperatures to print with.
So you can extrude it.
It's much easier to extrude.
Cool.
So, and it's just that I wanted to highlight this because it's a trend right now in terms of additive manufacturing parts for radiation protective purposes.
Sure.
And I wanted to link this back to an earlier article from 3D printing industry. USNC, the Ultra Safe Nuclear Corporation, totally sounds trustworthy. I mean, they are, but like, man, if this was a video game, that company would not be trustworthy with a name like that. USNC licenses Ornal, Oakridge National Labs method to 3D print nuclear reactor components, and I touched on this a while ago, weeks ago, and it was in the tech report. But it's just I just wanted to reference this quickly, as there is a demand for 3D printing components for radiation.
Yeah, absolutely.
And radioactive exposed components.
Extremely harsh environments.
Yes.
Yeah.
Yes.
Yeah. That is a fascinating look. So a lot of it depends on the application. Like in the plastic, the PLA situation, they're using as a shield, and the nuclear condition or example using a different application. I do like the, problem statement and does it work? I really like that Hackaday article.
Yeah. And not just like, problem statement, testing, observations, does it or does it not work?
Yeah.
And if it doesn't, they even have replacement solution.
Yep.
I don't give Hackaday enough credit.
The article I have is from Fast Company, and they talk about industrial origami. So for a long time, we've seen articles of additive getting into automotive. We've seen like some of the early examples of wheels being printed Then they started shifting to calipers, and then Singer started doing the entire body frame or components of the body being grown.
Singer with a Z
With
or
a
C?
C.
CZ?
Yeah. Hypercar
Right.
cost territory, not quite production, right?
I just want to make sure it wasn't like the Resto Mod company Singer that does 911s.
No, completely different Singer. And then
Both cool.
we've seen applications in bicycling and motorcycles.
Yeah.
Now we have a startup company that's looking at creating electric scooters by basically just forming material. Now, you could say you could use dies and presses to obviously form any type of sheet metal that's been around for a long time. But they're taking a much simpler approach where they're taking basically flat sheet and using brake presses to bend the sheet that you want. Basically, very, very simple forming along the same lines as origami. And some of the reasons that they're looking at doing this is for a couple of things. One is they've compared the components counts to for a off the shelf scooter. Around 130 components for a body for an older design.
Wow.
With this new process or revised process, they're able to drop 70% of that. Now they're down to 15 components for the scooter. So
that's wild for a gas powered scooter.
Correct. And so not only are you able to use less number of components, obviously you can bring in less material, right? You start off with a flat sheet and you're just bending and then joining as you go.
And that reminds me, I'm sorry, quick sidebar. There's a lot of attention in eco-friendly, environmentally friendly use of material. It's not that the material is specifically environmentally friendly, like it's biodegradable, but there's a lot of research showing that if the material is good enough and strong enough, you don't need to use as much. And that by default is environmentally friendly.
Yeah, I'll get to that in a second. And so the quote from the article is we're creating a strength in the structure that actually makes it possible to have substantially less material and substantially less weight. So to your point, they're able to design it and form it and get the residual stresses in the place that they want, where it's preloading and they don't have to worry about adding more material. And the other benefit is instead of being manufactured in a big factory where you need large space for forming presses, they're able to go to a smaller manufacturing footprint and produce much closer to the end customer. And getting to your point of sustainability, so there's a third party that did a life cycle analysis. So a lot of people are very interested in electric cars because of the low impact once they purchase and use it. But there's quite a few studies that if you look at the entire life cycle of harvesting batteries in the manufacturing process, the break-even point to the carbon footprint of a gas-powered car is about 100,000 miles. So if you're going to drive a car for 200,000 miles, you're net positive. But realistically, you're going to turn a car over every 70 to 100,000 miles. You're going to be consistently at equal to the overall carbon footprint of a gas-powered car in current manufacturing.
Wow.
So where they are now is that they feel that in their manufacturing process, they are significantly more efficient than producing that equipment, producing that good. And right now they're producing electric scooters, but if they're switched to gas powered, they think that the gas powered will be significantly longer, significantly less carbon footprint overall because of their shorter manufacturing process.
I don't know about you. That's music to my ears. As an enthusiast, obviously we can't burn dino juice forever, but it's good and it sounds even better.
If I was in the scooter market, I would jump on this.
Yeah. Very cool.
You got an article on additive machine visions and adaptive robots for additive?
Yeah. So Metrology News pulls through once again, and they have an article from February 8th yesterday. Additive manufacturing repair solution uses advanced machine vision and adaptive software. So this is basically a corporate financial announcement from Optomech. They're basically saying how they've just received or they've just filled an order, $1.25 million order for their AM solution that implements adaptive software, AI powered software for advanced machine vision to more effectively distribute additive material to repair worn components.
Gotcha.
And this is corporate level, but I have from 3dprintingindustry.com, a supplemental article of this from a few weeks back. German-Canadian project set up to automate 3D printing part repair using AI technology.
Cool.
This is very similar. It doesn't have, the buzzwords added to it of advanced robot vision systems or adaptive technology.
Yep.
At least it doesn't use the buzzwords, but it includes the same stuff. This is a collaboration between German and Canadian institutes and companies working for the same goal.
Cool.
They're not necessarily going for, they're just doing the research. They're not trying to sell solutions at this point.
Yep.
But it's a fascinating trend. And it's really exciting because, robots are not even speaking about additive yet, but robots are used commonly in automotive production, especially, for example, robots using to paint the outer components of a car, like the body panels.
Right.
And that employs a relatively dumb robot. It's an industrial robot. No humans need to be around it, especially if it's programmed perfectly, which if it's doing mass production, which cars are, especially something like Ford is, then it's programmed to do its job perfectly. And then it's, set it and forget it.
Right.
The problem with that is, it applies the paint and usually that's it, especially if it's an economy car. If it's, a higher level, like, luxury brand, it may apply a few layers of paint and then, a clear coat to protect said paint. But then it goes to the lot and it's done with it. However, if you're looking at like the super premium, like, an English brand car, like an Aston or a Rolls Royce, those customers who are spending that crazy amount of money and don't care about dealer premiums because of a silicon shortage, they want perfect paint. And they're willing to pay for it. They might not necessarily want it, but like they expect perfect paint. And to get that perfectly smooth, zero orange peel or swirl marks whatsoever, which you're not going to get swirl marks from the factory, but without orange peel, you're definitely not going to get that from a robot spraying paint on alone. That needs to be buffed by hand and smoothed out by hand. And then maybe a robot can apply a clear coating once it's been polished perfectly by hand.
Yep.
But, there's not robots implemented right now to do hand buffing because the components between vehicles and between parts differ.
Right.
Advanced manufacturing techniques, dictate that the parts might not differ that much, but the work holding absolutely will.
Sure.
And if you have a dumb robot, like, an industrial, like Generation 1 robot with a buffing wheel, you're going to get hot spots and it's going to ruin that body panel after another robot perfectly painted it, near perfectly painted it. So it needs to be done by hand, and adaptive robots will take care of this.
Nice.
And that's why the drive for these advanced vision systems and AI controlled robots, or adaptive robots, can detect these small nuances, not even changes or blemishes or just these nuances between parts in their work holding to hold them in place differs enough that it requires an adaptive touch to it.
That's
that humans have by nature, but which is
most
why
humans.
It's called artificial intelligence. Well, a trained human, can do this.
Yeah.
But this is it's very similar to that in that it's applying, when you're repairing a damaged or worn part, like, for example, a screw to a large ship or submarine.
Right.
If it's worn, they may wear similarly, especially if it's a well-manufactured part. It may wear in a predicted and controlled manner. But if it's damaged, then you absolutely need additive and high-tech vision systems so the machine knows when, okay, we need to apply a thicker layer here and a thinner layer here, and it needs to vary so you don't have, air pockets in the material being printed out.
Yep. Yeah. Explored that a bunch of years ago. So like in aerospace, repair is a huge aftermarket industry.
Yeah.
And, back to sustainability, I'm a big fan of repairing more as opposed to just replacing. So when you talk about big screws for boats and things like that, right? You could have a rotating inventory to keep your ship up and running. So you're going to replace it with a new one, but that old one, instead of just chucking it. You're just going to repair that and put that in your inventory pool. And being able to streamline that repair process. So like weld repair has been around for a really long time, but that's been done by humans,
right?
Because they can see the variation from part to part, even in variation within the defect itself.
Manual additive.
Exactly. And they can compensate, and either they'll excavate entirely and then they'll backfill it. But being able to shift to a more automated process where you don't have to program every single time, right? So that's the key, is getting to cutting material or getting to welding the part soon as possible. So yeah, I think that's a very good article. And I'm glad to see, we are doing significant more effort on streamlining the repair process.
Sure.
The last article I have is automation related, a new guide to automate existing machine tools.
I love this one.
And it's a good one to talk about. At my old factory, we had equipment that was like 30 years old, and this was 20 years ago. So they're probably still around, probably 50 years old at this point, where physically everything works, right? They're, machines that just keep producing parts as fast as that cell needs to produce. So the question is, how do you automate those type of pieces of equipment? And the article has some very interesting takeaways on getting to improving that process. Obviously, they make the case of why would you want to automate, and they talk about non-automated machines cut approximately 20% into a full day. And if you look at the entire year, that's about 1,700 hours or 8,700 total available annual production hours being used. So if you want to try and improve there, automation is one key element. And the article talks about two different paths: software automation and, of course, hardware automation, right? So the examples we've been talking about are physically connect to the part. And if you include AI, you're also including some of the software automation where you allow the decision making to be done on the fly as opposed to programming everything up front. And they give a pretty good guide of how you can optimize workflow and material using software, and then determining spindle time, using schedule builders, and optimizing raw material tools, and being able to keep the machine up and running as fast as possible, as much as possible, with digital automation. And of course, now that the information and tools are there, keeping the tool up and running as fast as much as possible by physical automation, and how to best implement those for existing tools. So I would say it's a good look, and everyone's looking at, if I automate something, do I have to revamp my entire factory?
Right.
At some point, you should be replacing 50-year-old equipment. But if you've already, it's basically free money.
If it's 50-year-old equipment, you're crushing it.
Yeah. So the key is, how do you grow that business, right? How do you continue harvesting more value from that aging equipment, which you can. You just
absolutely
want to run more. So it was a good guide, and that's a pretty good read from Cutting Tool Engineering.
I really like Cutting Tool Engineering because I don't want to call this a remedial article, but sure. I like every now and then they come out with like a simple article that gets you up to speed into a high level, like current state relatively quickly with minimal amount of text and in an easy explanation. Like, this is a bad example. I don't have an example offhand, but like I've posted articles from them that was like, what are cutting tools or what is CNC? Something like that.
Sure.
But like, they really are fascinating reads. Yeah. And this one, when it came across my desk yesterday, I loved it because, I've only been in this industry for like 6+ years now.
Sure.
But if I had a nickel for every time I was at a conference and, somebody asked either a speaker or during like a networking session, how do I get started with Industry 4.0? Especially that comes up a lot in like, the MT Connect working group, or not working group, but like that whenever MT Connect is discussed at a conference, how do I get started with Industry 4.0? If I had a nickel for every time somebody asked that,
that's a
which
lot of
this article effectively answers, I'd be retired by now.
We had a tangent while we're prepping, talk about retirement.
Yes.
All right, Steve, besides finding us in a retirement home in a couple of years, where else can they find more info about us?
amtonline.org/resources. We've got a lot more content there now.
Yeah.
We've got the MT magazine.
Yep.
Other things they can subscribe to, but especially the podcast and the weekly tech report.
Awesome, Steve. Thanks, everyone.
Bye, everybody.
Bye.